The purpose of this video is to discuss efficiency in Matlab, particularly as it pertains to calculations involving vectors and matrices. To use Matlab efficiently, it's helpful to understand the difference between compiled and interpreted computer code. When a computer program is written in a high-level programming language, a compiler is used to translate the program into machine language, the kind of code that a computer can run directly. For instance, the core of Matlab is written in the C programming language, although significant parts are written in Fortran, and I believe other languages are used as well. If you create a matrix A and a vector B in Matlab and then ask Matlab to solve AX equals B by typing X equals A \B, Matlab will execute machine code to solve the system very quickly. I'll show you an example in a moment. On the other hand, a user-written Matlab program, that is a program written in the Matlab programming language, is not compiled into machine code, but rather it's interpreted and executed by the Matlab software. This makes the code intrinsically slower. Therefore, for example, I can expect my own Gaussian elimination code to be much slower than Matlab's built-in solver, even though the two codes are applying very similar algorithms. Let's take a simple example before looking at the solution of linear systems. I'll create two vectors of length 100 million. Then I'll compute the dot product of these vectors in two ways, using the built-in multiplication operator and using an explicit loop. In both cases, I'll use the tick-tock mechanism to time the command. It takes a little bit less than 1/10 of a second to compute the dot product using the built-in multiplication operator. It takes about 15 times as long to do the calculation using an explicit loop. Next, I'll do an example that involves solving a linear system. I create a 500 by 500 random matrix and also a random vector of length 500. First, I'm going to solve the system using Matlab's built-in solver. That takes less than 1/100th of a second. Next, I'm going to solve the system using my own Gaussian elimination code. That takes a little bit more than a second, so more than 100 times as long. My Matlab function is interpreted and executed by Matlab, and therefore it's much slower than the built-in Matlab solver. The moral of the story is the following. If you want your Matlab code to be as efficient as possible, use built-in Matlab functions whenever possible. This is a programming tip that's unique to Matlab and other programming environments in which your code will be interpreted, not compiled. It really doesn't apply to programming in a language like C or Fortran, in which case all of your code will be compiled.